This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to show how to find the area of a sector of a circle. Okay, let's take a look at a problem and see what this is about. So your problem might be something like this. Find the area of a sector of a circle having a radius of 8 meters and a central angle of 45 degrees. Okay, let's draw a picture. So here's a circle, and the circle has a radius of 8 meters. We'll call that radius 8 meters, and a central angle that's 45 degrees. Okay, what we're looking for is the area of this sector, this wedge in the circle. So I'm going to call that area x. And I'll solve this by starting out with a fraction. The first fraction is going to have x, the area of the sector, as the numerator. And for the denominator, I'm going to put in the area of the entire circle. Remember, area is pi r squared, and r, in this case, is 8. So 8 squared is 64. That would be pi times 64, or just 64 pi. And now I'm going to make an equation. I'm going to set that fraction equal to another fraction. This fraction will have the central angle as its numerator. That's 45 degrees. I'll just write 45 over 360, the number of degrees in the entire circle. And now I just have to solve for x. Looking at this, I've got some numbers that I really don't want to multiply like 64 times 45. So let's simplify this 45 over 360. I know I can divide both of these numbers by 45. So what I'm going to have is actually x over 64 pi equals 1 over 45 into 360 is 8. Now I'll multiply both sides by 64 pi. Doing that will take the left side of the equation and leave me only with an x. The 64 pi will cancel out. And that's going to equal 64 pi over 8. I can simplify the 64 and the 8. I can divide them both by 8. So I'm going to have x equals, let's see, 8 pi. Okay, so the area of this sector is going to be 8 pi. We were dealing with meters. And if you want to, you can take that number, 8 times pi, and put that into a calculator and get a decimal approximation for what that area is. Okay, let's look at another one, this time with radians. Find the area of a circle having a radius of 15.2 feet and a central angle of 5 pi over 6 radians. Okay, so once again, let's do a picture. So I'm told that the radius is 15.2 and the central angle is 5 pi over 6. Well, that's almost 1 pi, so it means I've got almost a half a circle. So this is 5 pi over 6. And I'm looking for that sector, the part that's almost a half a circle. So we'll do this exactly the same way, except we're dealing with radians. I'm going to have x over the area of the entire circle. So the radius for that circle is 15.2. I want pi r squared. I'm just going to say 15.2 squared times pi, and make that equal to the central angle, which is 5 pi over 6 divided by 2 pi, since we're dealing with radians and not degrees. Okay, so let's do a little work and clean this up. On the right side, I've got this fraction, 5 pi over 6 over 2 pi. Well, let's simplify that fraction. Down here, I'm going to write 5 pi over 6, and we're dividing it by 2 pi. So I'll just write divided by 2 pi. In a sense, it's like 2 pi over 1. Remember, when you're dividing a fraction by a fraction, you can invert the second fraction. You could flip it and then multiply. So I'm going to have 5 pi over 6 times 1 over 2 pi. Well, when I do this, I can cancel out the pi's. I'm going to get, multiplying across, I'm going to get 5 over 12. That'll be a lot easier to work with. Okay, so I've got x over 15.2 squared pi equals 5 over 12. And now what I'm going to do is simplify the left side of the equation by multiplying by 15.2 squared times pi. And of course, I have to multiply the other side of the equation by the same thing. 15.2 squared pi. The left side of the equation simplifies down to just x. On the right side of the equation, I've still got 5 times 15.2 squared pi over 12. And we were dealing with feet, so this is going to be square feet. And what you want to do at this point is take this fraction, 5 times 15.2 squared times pi, that whole thing divided by 12, put that into your calculator and see what the decimal equivalent, the approximate decimal equivalent for this would be. And that would be the number of square feet in the sector. Okay? So for both of these problems, we did exactly the same thing. We called the size of the sector x, and we divided that by the area of the entire circle using the formula pi r squared. And we set that equal to a second fraction in which we had the central angle as the numerator, and then as the denominator either 2 pi if we're dealing with radians, or 360 if we're dealing with degrees. Okay? And that's about it. Take care. I'll see you next time.